Hello, this is the next video in a playlist that I'm calling Probability Measure, and here we're going to look at an example where both the Approximation Theorem and Caratheodory Extension Theorem fail. So the example is, let's let omega be the rational numbers, f be the field of finite disjoint unions of right semiclosed intervals of this nature, a comma b, where this stands for all rationals in omega that are between a and b, can equal b. Of course, a and b are rationals. Now, in order for this to be a field and hold up to complements and intersections and unions, we have to define these three sets as right semiclosed intervals. Now let's let the sigma field generated by f, or sigma of f, be the minimum sigma field over f. Now a few notes. All singletons are in the sigma field generated by f, right? Because if we look at this infinite intersection, it goes to the point x, right? And since it's a sigma field, it has to be in there. So hence, all subsets of omega are in the sigma field, right? Omega are the rationals, and every point, every rational is in this sigma field, but it's also in there, so all subsets of omega are in the sigma field. Now let's let mu of a be a counting measure, i.e. it's the number of points in A. Since omega is a countable union of singletons, mu is sigma finite on the sigma field. However, all non-empty sets of the field F have measure infinity. So observation 3 is that there are sets in A with measure zero, finite, so the counting measure is finite, that cannot be approximated by sets in the field F. So note that for all non-empty sets B in the sigma field, or in the field, the measure is always infinity. So hence this symmetric difference is always infinity. There's not a sequence Bn in the field that approximates A, where A is finite in the sigma field, right? So it doesn't happen. So the approximation theorem is not true. Now, observation 4, let's let lambda be 2 times mu. Remember, mu is the counting measure. So lambda and mu are equal on the field F, because every set is infinite. So mu of every set in the field is infinite, and 2 times infinity is infinity. So lambda is infinity, right? So they equal on F, but they don't equal on the sigma field generated by F, and that should be a 0. And that's because if you look at lambda of x, where x is a singleton, it's equal to 2, right? 2 times 1, mu is 1, so they don't equal on the sigma field, right? And so for all sets in the field, these two measures are equal, right? They're either 0 or infinity, but they don't extend, or they're not unique on the sigma field generated by that field, right? And so what went wrong? And note that the requirement of mu being sigma finite on the field is not satisfied, and that's why both of these theorems did not hold. Well, that's all I have for this video. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.